Right now, we have the Raspberry Pi Pico that we were using with CircuitPython connected to the PC. As you can see, the CircuitPython memory is connected. In this state, if you go to the link here, you can download the MicroPython firmware. If you scroll down, you'll see the latest version, including a nightly build, which is like a beta version. The official release is 1.18, which is the highest version. Please click on it to download. As you can see, there is a button labeled Boot Cell here. Now please press it and connect to the PC. Like this. If you connect while holding down the boot, select button as just shown, it will change to bootloader update mode, like this. In this state, please copy the UF2 firmware and paste it here. Then the connection will be lost and reconnected. For reference, in the case of MicroPython, it does not get recognized as separate memory like CircuitPython. But anyway, since the connection is established, the firmware has now been updated to the latest version of MicroPython. Next, please open Visual Studio and click on the extensions section, where you can search. Please search for MicroPython here, and you will find the MicroPython extension. Please install it. Now the installation is complete. In this state, if I open the panel and type MicroPython, there are only three options: Stop, Lost, and Getting Started. If you click on Getting Started, you can create a project. To create a new project, in my specific case, I will use the email folder located here, which will specifically serve as the root folder for my project. I will name it Hello Micro, and then select Get Excited and New Project here, after which I will verbalize Hello Micro. This is the port that I am using, and since 11.200 is the default setting, I will set it to 11.200. Now, a MicroPython project is being created. You can clearly see that there is a boot file and a main file present. The boot file corresponds to the setup, similar to the setup loop in Arduino. It is a script that runs only once when booting up. After the boot script runs, the main script is carried out. Additionally, there is something else to do. This is related to the MicroPython settings. In my specific case, I have installed MPI and RCL. But if you have them installed on your personal computer, you can check the location by typing location MPI, and it will show the path. You can copy the path and install it here, then paste it. After that, use RShell and copy the path to paste it here. For those who haven't been able to install it, you should install pip or pip3 first, and then use mfile or RShell to complete the installation. Next, you need to enter the path here for this extension to work properly. In my case, it looks like this. Next, it just says hello world here, but I will run an example that blinks an LED. For now, let's erase that. And we have set up the board in CircuitPython, but here we mainly use the machine module. From machine, import, pin, front time, print, slip, print, pin, wire, high. This is a simple process that involves using the machine to import the pin. Front time, print, slip, print, pin, wire, and high. Turn on the LED, then print LED on, and it will display slip, print, on. Once you turn on the LED, you should then print LED on, and it will display slip, print, on. Save this, and after opening the palette, there is a run option. Make sure to save this, and after opening the palette, you will find there is a run option available. When you run this, it will download it. To the Raspberry Pi Pico, you need to wait a bit. Now it is running, and at this point, the Python shell is executed immediately. In this state, when I run the program I created, pressing Ctrl-D will trigger a soft reboot, and the program will execute, turning on and off. Let me check it once. As you can see, it is controlled by GPIO 25. The LED turns on and off repeatedly. Now, if you stop a running process, you can specifically return to the shell by pressing Ctrl-C. From there, you can essentially check by importing machine and using dir machine, which will indeed allow you to see what pins are available for use. In this particular session, we installed MicroPython firmware on the Raspberry Pi Pico and set up the MicroPython environment in Visual Studio. From now on, we will very much continue with Raspberry Pi Pico projects using MicroPython. The example we will be doing this time will be stored in a separate and dedicated GitHub repository, and I will ensure to leave the repository address in the description section below this video. I will see you next time with different content.